All right, everyone, this is Dr. Zach. Today we are going to practice that disc washer method just a little bit more. So let's get started. For today's lesson preview, did you find that r of x was equal to the sine of x minus 2 and little r of x was negative 2x minus 3? Keep in mind you were revolving about y equals 0 and there was a hollow piece to consider when solving this problem. That made this a washer problem where you had to subtract away the hollow piece. So the difference between a disc and a washer: a disc has no hollow piece that needs to be subtracted, and the washer does. So here's a reminder. For your washer method, it's going to be your outer radius squared minus the inner radius squared integrated from a to b. Now, using your disc method, you have nothing to subtract out, so just pi r squared multiplied by thickness for both of those. And again, if you are perpendicular to the x-axis, you should be using x values. So you're going to spin x, use x. And if you're spinning y, you're going to use y values. Spin y, use y. Now it's important to make certain you understand how this is working, because we have a different method to use next class. So let's practice a few more of these so that you are really good at finding the volume. So today's lesson is to provide you with an opportunity to practice this disc washer method some more. So practice a few problems, turn off the video, check your answer, then practice some more. Go ahead and get started. So as you practice number 6, did you notice that there was an outer radius and an inner radius? Because as you draw from the axis of revolution to the outer edge, you had to pass a hollow piece. For question number 8, once you had the spinning piece was the y-axis. When you draw from where you're spinning to the outer edge, the radius took on a length of x, and we know that x needed to be solved for. You came up with r of y is the square root of 16 minus y squared. Just a reminder, you're using the y values when you set up this integral because you're cutting on that y-axis. So practice the next couple problems. Number 12 is actually 4 different questions. So give the next set of problems a try and then check through your answers. Okay, so as you check each one of your problems, make certain you have drawn your radius from the axis of revolution to the outer edge. As you draw the radius, that should indicate whether you have x's or y's being used, as well as if you have a hollow piece which needs to be subtracted. Now, for question number 12, you had 4 different problems. Each one involved a different setup with a different axis of revolution. Your answers do change depending on where the axis is because different shapes are being created. So look through it, make certain you practice the integration with your calculators so that you are set. Give questions number 16, 22, and 29 a try, and then you can check through your answers. Draw carefully when you're looking through your problem set. In this one, you were spinning about y equals 4. So the radius goes from the axis of revolution to the outer edge. Notice this is a solid disc problem. You do not have an inner radius to subtract off. For 22, be very careful when you find the region that you are trying to spin about the line x equals 5. When you draw, make certain the radius is drawn from the axis of revolution to the outer edge. You see that the radius is with respect to y, and you're going to get a 5 minus 3 over y. For question number 29, once you have your graph, notice that the shaded region has a hollow piece when you draw your axis, your radius from your axis of revolution to that outer edge. It has a hollow piece, so you're going to find big R of x minus, and then you're going to find little r of x in order to find the volume. For question number 54, something that might help, notice when you are spinning perpendicular to the y-axis and when you are spinning perpendicular to the x-axis. Give number 67 a good try and then work on your lesson follow-up. So question 67 is a fabulous little question just because you get to do both integration and differentiation in one problem. So as you were looking at your figure, you determined that r of x is 4 minus x squared over 4 minus b. And we're going to integrate this problem at the value I'm calling a. So you have two parts to your volume. You have the first part, which in case you're subtracting b, and in the second part, you're doing b minus the 4 minus x squared over 4. But because these are both squared, you can integrate from 0 to 4 with this function. Multiply it out, which is totally annoying, but you can do that, and then integrate. And once you integrate, you have the volume expression with respect to b. Now for question C, you were to find where the maximum volume occurs. So take the derivative of your volume equation, set it equal to 0, and you know the b value, because that's your critical number. If you use the second derivative test, you can see that v of b is always concave up. And since it's always concave up, you must have a relative minimum. Remember that you need to prove when you have a relative minimum or a relative maximum. So take a look at the lesson follow-up, do some of this practice, and you have a fabulous day.